So lesson number 2 is looking at radical functions again. Only this time what we're looking at is if we take a function and then take the square root or the radical of that function. So in each case, the graphing calculator screenshot of the partial graph is shown. This is the window that has been used. So what we're going to do is we're going to determine y equals the square root of f of x, then use the same window to graph the square root of f of x and sketch the graph on this same grid. And then we'll state the domain of the original function and the radical function. So if we look at the first one, f of x equals x squared, this is the graph of x squared. What is the domain of this graph? What are the possible x values?
Negative infinity, positive infinity.
Negative infinity to positive infinity. What is the range, the possible y values?
Zero to infinity.
0 to infinity, and it can include 0. Okay, so now if I grab my calculator, first thing I want to do is I want to set my window to be from -2 to +2 going up by 1s, and then my y's go from -2 to +2 going up by 1s. And then I can put in my y equals, I'm going to put in the original function x squared, and then y2 I'm going to graph as being the square root of x squared. So the square root of x squared. And then I'll graph the two functions. So if you notice, this function, this radical function, almost looks like it's two straight lines. It almost looks like an absolute value function. Okay? So if I sketch that in here, I get my graph kind of going like this. And those are the intersection points. If I was to determine what one of the intersection points is, and an intersection point of 1 and 1. Is that an invariant point in this case? So if x equals 1, what does y equal in my original function? It equals 1. 1 squared is 1. And if x equals 1 with the square root, I get square root of 1 is 1. So it's still, this would actually in this case be an invariant point, because that point does not change when I'm graphing the function from the original to the new function. What is the domain of this radical function? What are my possible x values?
Negative infinity to infinity.
And what is the range? 0 to infinity. Okay. So now if I look at graph number 2, I have a cubic function, f of x equals x cubed. What is the domain of this function? What are my possible x values?
Negative infinity to infinity.
Okay, which is also the same as saying x could be anything. X could be an element of the reals. So that's another way that I can express it. So I just want to keep going back and forth and getting you to realize that there's more than one way to write the domains, that we're not just looking at one form. What about my range? What are my possible y values? Y could be any real number because I could have negative values. So now again, we're going to put this into our calculator. So y1 equals x to the power of 3 this time. And then y2 is going to equal x to the power of 3. Now, if you want graphs, if I scroll my cursor over to where the line is beside Y2, if I press enter, it'll change the thickness of the line, so I'll be able to see when that new graph is being drawn. So if I press graph, there's my x cubed graph, and then I get this thicker graph that comes in. And this thicker graph does show a little bit of a curve. It's not the straight line that the other one was. But what do I notice about this line? Where does it start at?
The y-axis.
It starts at the y-axis. It starts at 0. Okay? If I was to look at the table of values, just a second. If I look at my table of values, I've got when x equals 0, both graphs equal 0. When x equals 1, both graphs equal 1. Then they start to change. If I move up, when the x values are negative, the second graph no longer exists. So then I've got this that kind of goes like that, a little bit of a curve to it. So what is my domain of this graph? What are my possible x values?
X has to be greater than or equal to 0.
And what about my range? What are my possible y values?
Y has to be greater than or equal to 0.
And the reason for that, if x is a negative value, when I take the cube of a negative value, do I get a positive or a negative answer?
Negative.
I get a negative answer. And can I take the square root of a negative answer? No. I'm sorry, I forgot to write that this was x cubed for my equation. So now I'm going to give you about 5 or 10 minutes. I want you to do the next, or I'll give you about 5 minutes to do 3 and 4 and 6. Don't do 5 yet because we haven't talked about logs. So I just want you to do 3, 4, and 6. So if we look at question number 3, f of x is equal to x plus 1. So the square root of f of x would be the square root of x plus 1. So when I look at this equation and I look at the domain and the range of the original function, the domain and the range are both that they could be element of the real numbers. There are no restrictions. So x could be a real number, y could be a real number. Or they could be from negative infinity to positive infinity, is how I could write it. When I go to take the square root of that, what I end up getting is I end up getting this graph that kind of looks like this. So it's got this arc to it, and it does start in the negatives. Because in this case, if x was equal to negative 1, I could still put it into this equation, because I'd get 0 and I can take the square root of 0. So the domain this time is that x has to be greater than or equal to negative 1. And then the range, again, is that y has to be greater than 0. So set a y value such that y is greater than or equal to 0. So then if we move down to number 4, where I have an absolute value function, if I take the square root of the absolute value function, this is what I end up with. And when I take the graph of, the domain and the range of my original function, f of x, x has to be, or x could be anything. So negative infinity to positive infinity. Y has to be greater than 0. So 0 to infinity. Then when I go to take the square root of this function, what did you notice this time? What did it look like? Was it straight or did it have a curve to it?
Had a curve.
Had a curve to it. And the curve started, it's kind of on the inside of the graph and then moves to the outside of the graph. So the domain and the range of this new function end up being the same as the original function. I can have negative x values this time because any negative x value is going to become a positive when I take its absolute value. So this time I can have negative x's. And I said I'd skip v because it deals with logs and we haven't gone there yet. So then I'm going to skip to 6. Y equals f of x equals negative x squared minus 1. So if I look at this graph, what is the domain of this graph?
Oh, x can be element
X can be a real number. What's the domain?
of y such that y has to be less than or equal to negative 1. And then
So y is less than or equal to negative 2, and it can be a real number after that. What happens when you go to take the square root? So when I take the square root, I get negative x squared minus 1. And what happens when you go to graph that function? It doesn't show up. Now, does it not show up because it's not in the window settings, or is there another reason why it doesn't show up?
It's not possible? I don't know.
So which one is it? Is it just that the window settings
No,
aren't
it's
the
that
right
it
one,
doesn't.
or is that it's not possible?
It's not possible.
So the graph, this, does not exist. And the domain and the range do not exist. So it does not exist for the domain and does not exist for the range. Because there is no possible x value that I can put into this graph that is going to make what's underneath the radical sign positive. Every number I put in for x is going to give me a negative result because this negative is not attached to the x squared. So it means I would take whatever x squared is, or whatever x is, square it, and then put the negative on it and subtract by 1. So it says, repeat the work in question number 1 on the previous page for the functions below using the following window. So the window settings have changed. They're a bit bigger, and I'm dealing with 2 quadratic functions. So I'm going to give you a couple of minutes to do this one as well. So if we take a look at question, this is 7. So the domain of my original function is what?
X can be any element of
X can be anything. What about the range?
Y has to be greater than or equal to 4.
Okay. So then the square root function becomes the square root of x squared plus 4. So when I graph that, I get this, it almost looks like it's going to be like almost a much larger parabola that goes this way. So again, what would the domain be?
X can be any number.
X can be any number. And what is the range?
Y has to be greater than or equal to 2.
Right. How do you know it's 2? Did you just look from what the graph was, or is there?
Well, square root of 4 is 2.
At this point here, which looks to be the minimum, x is equal to 0, so then I get the square root of 4. Okay, and then if I look at the last one, before we start to put all of these together for patterning, the domain, again, x could be anything, so from negative infinity to positive infinity. The range is going to be greater than or equal to negative 4, so that would be going from negative 4 to infinity. Then when I go to graph this, I get some interesting pieces because I get a graph that kind of shoots out this way. That's not right place that I want to, like that. And then I get a graph that shoots out on this side. Kind of like that. So then when I start to look at the domain, I end up getting two pieces of the domain this time. I get this piece of the domain that is everything less than negative 2. So that could be going from negative infinity to negative 2. Or going from positive 2 to positive infinity. And what's my range?
Oh, it has to be 0 to infinity.
0 to infinity. And the reason for that is because in this part of the graph here, I get these negative x values, which again, when I try to square root them, I end up with an unreal value or a non-existent value. So in which of the examples from question 1 and 2 were the domain of the original and the domain of the square root the same value? So where did I have the same domain? So the domains were the same in the first one. And they were the same in number 4. And again in number 7. So 1, 4, and 7, I had the same domains. And it said, what do the graphs have in common that the other graphs don't? So why were the domains the same? So if we look at the graphs, if you look at this graph, the graph is up here. If I go to 1 was up here. 4 was up here. So in all of these cases, the graphs occurred above the x-axis, which means that in these cases, for any value of x, the function was always positive. So then the square root of f of x is possible. Remember, in order to take the square root of f of x, I need to have a positive value. So it says, from the options in the curly brackets, circle the correct alternative in each statement. So the graph of f of x does not exist when the value of x equals 0 or when f of x is less than 0. So is it when the value of x is negative or when the function is negative? The function. Because we do have an example when f of x was, or when my x values are negative. Right here I have negative x values and I still can take the square root on this part of the graph. So it's when the value of the function is negative. This part here, this is the value of the function. If f of x is equal to 0, the graph of the square root of f of x lies above, on, or below the graph of f of x. So when f of x is equal to 0, that's when it crosses the x-axis, where does the square root function fall? So in this case here, f of x is equal to 0. The square root is also in the same place. If I go back to the previous page, this is where f of x is equal to 0, and that's where the other function starts. This is where it's equal to 0. This is where it's equal to 0. So is it above, on, or below? It's on. Because when f of x equals 0, the square root of 0 is going to be 0. So it's going to lie on the graph. When the value of f of x is between 0 and 1, where does the graph fall? So if we go back, where it's between 0 and 1. So when f of x, so f of x is not between 0 and 1 in this picture. But right here, between 0 and 1, that's this part right here. Is this above or below? And this one's probably not a great example to use because it's pretty squished. But if I go on to the previous page, this is between 0 and 1. Is this above the graph or below the graph? Above. So if I look at this one, between 0 and 1, am I above? This one, between 0 and 1, am I still above? So between 0 and 1, I'm now above. When f of x was equal to 1, what's the square root of f of x equal to? So if f of x is equal to 1, if I put 1 in for f of x, what do I get? 1. So these two values are the same, which means it's going to be on the graph. And then when f of x is greater than 1, I get that transition. So again, if I go to the previous page, when f of x is greater than 1, it's now going to be below the graph. When it's greater than 1, I'm now below. Greater than 1, I'm now below. So when f of x is greater than 1, the square root of f of x will be below the graph. Okay? So question 4 says, let's look into more detail at the graphs containing oblique straight line segments. So oblique straight line segments means that they're a straight line, but they're still kind of on this a little bit of a diagonal. So this is considered the straight line part of this oblique. Because it's not entirely straight, but there is enough of it that makes it look straight. So the graphs of y equals f of x and y equals the square root of f of x are shown below. So this is x plus 1 and the square root of x plus 1. In both cases, the graph of the square root is curved, similar to the shape of an open umbrella. In mathematics, a graph which is curved like any part of an upturned U shape, so there's my U shapes, is called concave down. If any part of the graph contains an oblique straight line segment, then the corresponding part of the graph will be concave down. And you can investigate this using a graphing calculator. What this actually means, when you are sketching the graph of y equals the square root of f of x from the original function, there we go. When f of x is less than 0, the square root function does not exist. When it's equal to 0, f of x is equal to 0. When it's equal to 1, f of x is equal to 1. Those give me invariant points, so I can plot those points. Then when I'm between 0 and 1, the graph is going to be above. When I'm greater than 1, the graph is going to be below. The values of f of x are the square roots of the values of the original. Choose values that have simple square roots, such as let f of x be equal to 4. Then the square root is going to be 2. So if I let f of x be equal to 4, this is going to be 2. So I look for 4 on the graph, and then I can graph 2. I look for 9, then I can graph 3. Things like that. If there are intervals containing oblique straight line segments, f of x is going to be concave down in those intervals. So now we're going to put this together. So if we look at the examples that are on the final page of the lesson. This is the graph of f of x. You cannot put this into your graphing calculator because there is no single equation that would connect all of this. So what we have to do is we have to use the knowledge from those characteristics. So wherever f of x equals 0, the square root is going to equal 0. So these points are going to be on my graph. Anything that's less than 0 will no longer exist. So this part of the graph is gone. This part of the graph is gone. When f of x is equal to 1, the square root will equal 1. So here's where f of x equals 1. So this point will exist. This point, and this point. All of those points are going to exist. And then the other thing that I can do, this part here, when f of x is equal to 4, the square root of that is going to be 2. So from here to here is going to have a value of 2. So I can draw that part in. Now remember what we said before, between 0 and 1, the square root is above. So between 0 and 1, I'm going to be above. So there's the curve. Between 0 and 1, I'm going to be above. Above, and above. So all of those become curved areas. And then anything greater than 1, I'm going to be below. So this is where trying to draw this as a smooth curve, like that. And then I'm going to connect this point to here, thinking that all of these are going to be the square root of the values below. So the square root of 3 is like 1.7 something. So I'm going to be like there. And then this part in here gets joined something like that. So what I'm going to look for when I mark is the invariant points, the zeros and the ones, and then between 0 and 1 showing them above, and then this part in here showing it below. And like I said, take a point that you know, such as 4, and when I take the square root of it, I get 2. If I had had like 9, I would have taken the square root of it and gotten 3, and then graphed that part. So if I look at my original graph, f of x, the domain of that graph was that x could be anything, because these arrows are pointing down. And the range would also be that y could be anything. When I look at the square root, the domain can only be from -3.
This is good.
Yes.
Why can y be anything? Because don't you have a maximum point at 4?
Oh, yes, I do. Sorry. So y has to be from -infinity to +4. Sorry. What's the domain of my radical function? -3 to 16. What's the range?
And 0 to +2.
Yes. And the last question asks to determine the domain and the range of the reciprocal function without sketching the reciprocal function. So if we look at A, what is the domain of this function?
X can be anything.
X could be anything. And what's the range?
Y has to be greater than 3.
Y has to be greater than 3. Okay. And what can you tell me about this function? Where is this function situated? Above the x-axis. So what that means is that g of x is always greater than 0. So g of x is greater than 0 for all values of x. That means that the domains can be the same. So that means if the domain of g of x is a real number, the domain of h of x would be that x could be a real number as well. And then the range of h of x, the range of g of x is 3 and up. So in h of x, I have to take the square root of 3 and up. So it would be the set of y values such that y is greater than or equal to the square root of 3. And then y could be any number after that point. What do you notice about the graph in B? Parts of it are above and parts of it are below the x-axis, which means when I take the square root, these two sections of the graph no longer exist. So those become areas that are no longer in the domain. So these do not exist in the graph of h of x, which is equal to the square root of g of x. So then the domain of h of x is from -3 to -2. That's this part right here. So -3 to -2. Or this part in here, which is 3 to 8. I think that's a 3, right?
Mm-hmm.
So from 3 to 8. And then the range, well, if I look at the range of these values, I'm going from 0 to 9. So h of x is the square root of that, which would mean the square root of 0 is square root of 9, 3. And then I have here, which is square root of 4 is 2. So that's still encompassed in that 3. So this can go from 0 to 3. When I'm doing two pieces of a domain, I have to use the word or. It can't be and, because it can't be in both the domains. It's either in this one or in that one is where I'm going to find the value of x. I can't find it in both. Okay? So your questions are 2, 5, and 6.